Yes, we did. Are we coming in? Is the signal clear? Okay. I don't know how much time we have, folks. We have to be very quick about this. Your mission, should you choose to accept it, is to join this live stream hosted by me, Brian Sapinski, and my daughter, Brianna, as we try to help you with your distance learning math lessons. If you have a topic that you want to submit, please go join the live chat, leave a comment down there, or send me an email directly at brian.sapinski@gmail.com. We'll get as many of your topics in before the signal collapses on us.
Where'd you get another green chair from?
YouTube is crashing everywhere around us. We don't have much time. We have to do this as quickly as we can. So please help us in our quest to save the world from math anxiety. It is vital. Okay, all right. Overly hyped Mission Impossible drama aside, welcome once again. And the good news is we have somebody waiting in our live chat queue that wanted to get had some questions about some geometry-based things. So we've got something to start with today. Yay, hooray for one of my students. Okay, but please, anybody from anywhere all around, please join us and stuff like that.
I know my friend, she needed some help or something. But
okay, then why isn't she here?
I don't know.
Well, go get...
I told her about it.
Go get your phone and tell her we're on the air. And tell her to get here quick. All right, but follow me with this now first here, okay? Because I want you to focus on something. Okay, our subject that our friend is online is asking here is with regards to triangles. Okay, I was starting to say this yesterday before we got cut off. Okay, and understand these figures, Brianna, are not totally drawn to scale. Stay with me here. All right, but just run with me here. You remember how yesterday when we thought we were still going, you remember I was starting to place markings around the pentagon that we had.
Mm-hmm.
I was starting to mark segments like this, for instance.
Where'd you get another green chair
and things wherever from Joey's room. They were from his room in the first place. So anyway, here's the thing.
I realized I'm suddenly
yes, so you can't fall over. Okay, anyway, so yes, we've had that issue of those of you who've been joining us the last couple of days, or trying to at least. Anyway, so here's the story, Grant. Anytime when you look at either a single polygon or you look at over multiple figures, anytime you see it where two line segments are marked the same way like this, okay, this indicates that they are the same measurement. You with me, Brianne? Okay. And there's a word for that when they are like that. And it's a word that geometry students have to have pretty much infused in their brains. It's called congruent. Like I said, that's just a fancy way of saying that they are equal in size and measurement. So in other words, Brianna, if this side measured 6 centimeters, then this segment would measure 6 centimeters, just like that. Okay. Now, one of the big principles that my geometry students have to do when they are seeing triangles or whatever is if they're shown two triangles and they have to try to prove if they are completely equal to each other all the way around. There are a few different rules by which they can try to see that. And what we're doing in this first part is to show off those different rules. The first one we abbreviate as SSS. Okay, that stands for, so you can see it, Brianna. That stands for side, side, side. Okay.
Yeah.
Basically, what it amounts to is, okay, here's this segment and this segment. Are you looking?
He's seeing triangles.
Oh, haha.
Triangle.
Does it feel that complicated, Matt? Watching there, does it sometimes look like you get mesmerized when you're seeing all these triangles together on the page over and over again? Let me know. Join in the banter too. That's what we're here for as well. Just to to make light of this a little bit.
Triangles.
Okay. They're everywhere. They're everywhere. They're everywhere.
Triangles. You see a triangle.
Yes. Anyway, okay, all right. Humor aside. Okay, so Brianna, so take a look. So what this rule would mean is that okay, you've got one side on each triangle that are the same measure. You've got a different pair that are the same measurement, and then there has to be a third pair. Mark the third pair. Put 3 tick marks on the third pair. And do it on the other one. Okay, so that essentially tells you which segments are are equal to which segments in length. Okay, and you could say that the 2 triangles are completely the same size and shape if this rule is satisfied. Now, sometimes the triangles are completely separated from each other like they are here. Sometimes, though, they're linked together. Okay, let me give you an example of one where they're linked together, for instance. And I'm just borrowing from for those that are doing my distance learning assignments, this would be question number 8 on their day 6.
Can the people watching the live stream see this?
Yeah, they can't see this, but they can see.
They can still see it.
Yeah, no, but I'm duplicating the question so that they can see it. Okay, so the picture. So the picture is showing this is in number 8 in my distance learning assignment that I gave my geometry guys on day 6. So Brianna, take a look. The picture shows this. Now, the thing you got to see here, Brianna, is, okay, you can see that the 2 triangles are connected to each other. Where are they connected to each other? No. Where are they connected?
Oh, this one.
This line down the middle. So here's the thing. If you're trying to use this rule, Brianna, if you're trying to use side, 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 okay, here's a pair.
Would it work?
Here's a pair of sides that match. Here's a pair of sides that match, but there has to be a third pair of sides. Where's the third, quote, pair? Right down the middle. Yes, because since this side belongs to
both. Kind of looks like a boomerang.
Sort of, okay. But here's...
Just gotta add the line.
No, wait. We'll get to that in a minute.
No, I'm saying like... To make it look like a boomerang. No. Lines on the side.
Okay, no, but that's something else. Wait, don't get that involved yet. We'll get back to that in a minute. Okay, but here's the thing, Brian. Yeah, this is where you'd mark the third one. And the thing is that, like I said, if you were to split these 2 triangles up, if you were to draw them separately, and again, ignore artistic imperfection, folks. You have this, but then, like I said, this side here, they're both this one down the middle. So the fact that both triangles use that side, that makes it automatically equal to itself. There's a rule in math, and this is true not just in geometry, Brianna. This is true of any and all math or whatever. Anytime you have it where something is equal to itself, okay? Anytime something is equal to itself, that's what's known as the reflexive property.
I've never heard of that.
You'll start to see it the more you get into algebra and things like that down the road. But all you got to really know about it is that any number or geometric shape or any type of thing like that, mathematically speaking, any mathematical object is always going to be equal to itself. So like for instance, just taking it in straight numbers, the number 6, okay? There's literally only one single number that 6 is equal to. Exactly, yes. It's basically an identity function. It's like, this is me. This is what I am. I am nothing else but this. That's what the reflexive property, that's essentially what the reflexive property is. Well, who is that?
Triangle Man.
Triangle Man, Triangle Man. Triangle Man hates Particle Man.
What?
They have a fight.
Oh,
Triangle wins. Triangle Man.
No, it's a different triangle. It's a different Triangle Man.
How many They Might Be Giants fans do we have out there?
No, it's a different Triangle Man.
No, come on. We got to run with that. You made that too easy. I gotta remember that when I redo my triangle videos. Okay, I have to remember that. I need that. I'll have to redo that song or
Isn't
whatever.
it just like a
But moving on. Okay.
fat person
All right,
with
but
a triangle head?
okay, but no, not necessarily. I'll show you. I'll show you later. Okay, but that's the kind of thing that you're looking for. But when you have triangles that are linked to each other, anytime you can mark those lines down that are those connected lines down the middle and get a side going.
Who's Big
That's it.
Blue?
Go Big Blue. Who's Big Blue? Fill me in on that one, Matt. Who's Big Blue? I want to know what you're talking about. But anyway,
Giants?
huh?
A Giants fan?
Oh, the New York Giants. Oh,
Yeah.
I get it. I'm talking. No. Yeah. Thank you. Yeah. Okay. No. Yeah. No, Matt. What I was talking about is no. There's like sort of a weird novelty musical act that's been around for a few decades now. The name of the group is called They Might Be Giants. And one of their songs, the song I was just quoting some lyrics from, they had a weird song called "Particle Man." If you get a chance, look it up, and like I said, probably the biggest.
Wasn't like Particle Man a duck?
No. Well, wait, that's when Tiny Toon Adventures brought their music into the forefront. Probably the two biggest songs that you probably would have ever heard of from They Might Be Giants. Actually, the three biggest songs you probably ever heard from them would be Particle Man, a song called Istanbul, Not Constantinople, and probably their most famous one in most recent years. They did the theme song for the kids show, the Mickey Mouse Clubhouse on Disney Junior. They did that theme as well. So look up those three songs and get an idea of like what they sounds like. Like I said, they're very quirky, but you'd enjoy them a lot. Okay, all right,
He
okay.
doesn't like Particle Man.
Yes, she remembers the music video that Tiny Toon Adventures did way back when. That's probably where a lot of people became fans of They Might Be Giants through when they got showcased there. Okay, all right. Let me go to the next thing now.
But
as far as
this is
congruence.
nice triangle, man. This is a different triangle.
So you say. Okay. All right.
It is.
Okay. All right. Okay. All right. Let me go to the next thing. Okay. So now let's take a look at another one. Okay. We talked about side, Brianna. Okay. So now I'm going to change this one here in the middle. I'm going to keep these two, but now in the middle, I'm going to put an A. Okay. What's the A stand for? These are sides. What are these in between? What are these? We've talked.
Fast.
Wait. What are these called? What is it called? The corner of a triangle. What is it called? That's an angle, right? Okay, side, angle, side.
Oh.
So notice the way that looks, or whatever. Okay, you still have two pairs of congruent sides. Yes, we've got to feel sassy about this. We need to. It depends on our survival.
Sassy.
Okay, so anyway, let's move on. Here. Because again, remember, we don't know when we're going to get cut off. Okay, so take a look.
Sassy.
So take a look here. So for side, angle, side to work, you still have one pair of congruent sides. You still have another pair of congruent sides. And then notice how both of those sides, they meet at one specific corner, okay? At that corner, both here and here where they meet, you have to have the angles at those two corners. They have to be equal in measurement as well for this rule to work. So this is okay when you see it like this, but it would not work. But it would not work if these were over here instead. That would not work.
Yeah, because
this would not be side, angle, side. Okay, because
it's
the reason why it wouldn't work is because
like they're not by each other.
Well, here's what here's why it wouldn't work. Here's why it wouldn't work. Because what could happen is in one of the triangles, because there's no fixed measurement for this angle here, I could take this side here and I could flex it. I could flip it over here. I could send it this way. Bear with the imperfection. This could still be the same measurement as that, okay? but this side is now completely different from this side, so it wouldn't work anymore. So that's why you've got to have this angle sitting in between the two congruent sides in order for everything to stay locked and rooted in the same place. So it would have to be here and here. Okay, so again, that's what it looks like separately. Here's an example of what one looks like when the two triangles are fused together. Okay, so what about one like this? If you're looking, my geometry guys, if you're looking on your distance learning assignment day 6, this is what question number 6 looks like. It looks something like this. So here's an example of that. So here, can I make a side angle side out of this setup? Look at each of the two. Look at each of the two triangles separately. Okay. Do you have first?
Yes.
Okay. All right. What's missing from the SAS right now in the two triangles?
So the second one. The
second side. Okay. Where can I put the second side to make it work? It's got to look like these two. No. Look. See, remember, this has to be in between. Right there. Yes. It's another reflexive property right there. Okay. Because now, if you look at this triangle, Brianna, if you look at this triangle, here's the two sides. Here's the angle that connects them. Look at the one at the bottom. Here's the two sides and the angle that connects them. That fits the side angle side rule. Okay, so that's the way ones like that work. Now sometimes there's another thing that could happen here. What if let's say this? Does it happen here on any of these? Shoot, no, it doesn't. Oh no, wait, yes. Okay, all right, it does and it doesn't. Okay, I'm looking at number 7 now. Okay, this is number for again my geometry guys. This is number 7 on that same day 6 page. Okay, because there's
doesn't hate particle man anymore because he's
giving them toilet paper. Hoarding is wrong, folks. Under any circumstances, not just a pandemic.
Look, he's giving you toilet paper, so he's happy because he ran out. He's happy now.
What is it?
What?
Okay. All right. Okay, stay with me here. Stay with me before we lose control of this. Okay, all right. So take a look at this. So take a look at this one now, Brianne, because in this one, okay, we got a little bit of a problem here. Okay. This time, as you look at the markings in these two connected triangles, okay.
They're different.
Okay, well here, what mark is missing from the rule? Okay, we're missing the angle. Now here's the thing. Now notice how these two triangles, how they're connected right here at the middle at this one single point. You see where they meet right here, Brianna? See that? Okay. Here's the thing. Anytime you have two lines that cross each other when they make that X formation, all right? What happens is that you see that you can make 1, 2, 3, 4 angles. Okay? Because if you use any two pieces of those lines, you could create an angle. Here's what happens. These two angles up here and down there, as well as these two angles over here and over there, I'm marking them with different arrows. Those pairs of angles at the opposite corners of the X, they're equal to each other in measurement. Okay? So that one and that one, yes. Those are what are referred to. There's a name we use for that. That's what's called vertical angles. Okay? So anytime we have two lines where we have an X formation like that, we can mark the angles at either ends of them and call them vertical. Now, having put that there, here's my question. Look at the 3 markings here and look at the 3 markings there. Do I successfully have side angle side in this picture at the moment?
Yes.
Well, here, let's see. Let's look at the top triangle. Do you have because they both have 2 sides and angle, but here's the question. On the top one, is the angle mark here in between the 2 sides? Yes, okay, because you can see this line goes to this point, That line goes to that point. That connects them. Is this angle in between those two sides?
No.
No, it is not. So there is no SAS happening here. So there is not enough correctly marked information in this to prove that the triangles are congruent. Yeah, not even that. So, all right. But now here's my question then. Okay, what for this to actually be side angle side, where would fix one of these markings here and put it where it would have to go to make this actually be side angle side? Because right now it's not. Okay, remove it from there and put it where? Yeah. If it looked like this, then it would be side angle side. Okay, so that's what you need. That's what you need to see in order for it to work properly. So just make sure that
I made a new one.
So just make
side
sure.
Angle, no.
Yeah, yeah. Sand congruence. Okay.
Side angle, no side.
Yeah. So in that number 7 problem, we had two triangles, sans congruence. Okay.
Sans.
So who knows? Okay. I'm gonna run out of room if you keep drawing here.
You said sans, and I'm drawing sans.
I mean, I was not trying to make an Undertale joke here. You don't even play Undertale.
I know, but I heard of it. I know.
God.
You said sans, so. That's.
Oh, good Lord.
I know, but I know about Undertale.
Are you getting this at all, Matt? And hey, Tamori, good to see you. If you have a topic as we're moving forward here, chime it in, Tamori, whatever it is that you like. I'm gonna continue my triangle discussion just for a couple of minutes here. Okay, here's the next one we're gonna look at, Brianna. New rule. Okay. All right. So here's what the next rule looks like, Brianna. Okay, and you tell me what this rule will be called. Oh, wait, phone's ringing downstairs. So okay.
What are you trying to do?
Okay, so we've talked about side. Well, here I'm running out of room here. Well, okay, I'm sorry, I'm running out of room here.
But you said
I need room
instead of sand. So
I need room, you crazy. Okay.
But really, you said sands instead of sand, so might as well.
I meant sands as in without. Okay, it's not there. It's not present.
No.
Anyway, all right. So okay.
It's sand, not sand.
But I needed that to make.
No.
Okay. Can we move on? Here's the next one, Brianna. What name would you give to this one? We talked about side, and we talked about side angle side. What would you call this one? Okay, angle side. Angle. Got it. Yes, angle side angle. Okay. Yeah, because now this time you have two equal angles instead of two equal sides. And in between them, connecting those two angles is a segment that's congruent, okay? So this is what angle side angle needs to look like, okay? So you've got that. So here's what they look like separately, okay? Here's an example of what one would look like when they're together, okay? For any of my geometry guys, this would be our day 7 packet there or whatever.
No.
Okay.
Let's
see an example of what that one would look like. And good Lord, what did they give you guys here?
What the heck?
No, it's not that. No, I'm just saying
it.
No, wait. I'm trying to find one that works or whatever. Were there even any on this picture? Jeez. Okay. Notes to self for my geometry guys. I'm looking at the day 8 paper. I didn't write these pictures, but I'm noticing that there's a number of places where I'll be honest with you, I don't even see an angle side angle anywhere on this page. Okay, so here, I'm going to invent one. I'm going to invent one so you can see exactly what it was supposed to look like, okay? Again, going on connections, all right? So follow this. Okay, so let's suppose you had this, Brianna. Okay. The question is, could I make angle side angle out of this picture? Now, if you think back to the last diagram that we had here, again, where do the triangles touch? Right there in the center. Again, what happens there? Where can you, when you have that X, where can you mark them? Right there. Okay. All right. Put a double on it to differentiate it from that. Yeah. You always want to put a different number of markings because, like I said, the ones with the same markings are the ones that have the same measurement. So unless these two measure the same as those two, you got to put a different marking on them to tell the difference. But that would be an angle side angle. That's the way that would look. Okay.
It looks like an
like sands through the hourglass. So are the days of our maths. Now I'm getting into soap operas here. Good Lord. So I'll tell you later. It's still on the air today, but the gag is before your time. So that's the way. So that's the way angle side angle would have to look. All right, here's another one that would fit the angle side angle model. All right, this one's very simple in design. What if you see something that looks like, let's say you had some.
Oh, this is number 8.
Not really. I'll get to 8 in a second. I can demonstrate number 8, but that gets to the next rule. We'll talk about a second, okay? Could you make angle side angle out of this one? What's missing in the name? The side, because you've got one angle, two angle, one angle, two angle, but the side, okay. And there's that shared reflexive property side in between. So an ASA can look like that. As long as they're like this, kind of think of it like you sort of have like tic-tac-toe, 3 in a row happening here. You know, Brianna? Because it's got to sort of look like that.
Is a diamond-shaped master ball.
There are no diamond-shaped master balls.
But if there was, that's what it would look like. Do you see the similarity?
You know how cracked those things would get?
Huh?
They would get so blunt at the corner, get so blunt and broken off from the corners from people throwing them all the time. That's why Pokeballs are round. You know.
What if they were square?
No, same problem. No, they can't have any corners. They've got to be completely round, or they're going to get broken too easily. That's why you don't say. Oh, stop!
Wait, I want
more. No eggs either.
This?
No.
And another one.
They're not like pearls. They can't be Baroque. Anyway.
What about this? I know. What about
Can I move on?
What about egg shape? Why can't it be egg shape?
No, those will crack under pressure too, but I'm bummed. Anyway, okay. So all right. Here's the fourth rule. Here's the fourth rule. All right, give me a name for this one. Now, what would you call this one? And this one actually has some questions on the worksheet that I could demonstrate or whatever. You got the right idea. You got the name backwards though. We don't say side angle revert, switch it around. We call it AAS, angle side. But you have the right idea that this time you still have two angles, you still have a side, but this time the side is not connecting the two angles.
It's touching one side.
No, there is no such thing as that. That does not work.
Okay, good thing.
No, don't worry. My students will make jokes about that all day when they look at the initials. Okay, so don't bother.
Lord.
Don't bother.
Because I know what it was.
Yeah, I'm aware of that.
No.
Okay, so a matter of fact, a few minutes ago we proved when we were showing side angle side, we proved why that one does not work. So we'll talk about that in a second. But now you'll notice in the AAS, this time now the side is only touching one of the two angles, but you also have to make sure it's touching the same angle in each picture. So this would be okay, Brianne. Look at that. This would be okay to represent angle, side. This, however, would not. Put the angles in the same places, but let's suppose that this side was connected to the second angle, but this one was connected to the first. That's no good. That would not be angle, side, because the marking.
Yes, angle, side.
But this side is connected to the second of the two angles. This one is connected to the first one. They have to be touching the same things.
That means it would be side, angle, angle.
No. That doesn't work. No, it doesn't work at all. The markings have to be in perfectly matching locations, or it doesn't, or the rule doesn't fly. Okay, so that's why that one would not work. Okay, so like here's a connected example, for instance, of one that works here. Okay, this is for those of my guys looking at their distance learning day 7 sheets. This is actually the very first question. Okay, so something like this.
Day 8.
Okay, but some people are catching up because they were having trouble with this. That's why they came today, and I thank you guys for coming.
Or maybe they're just doing them out.
Or whatever it is.
That's what I'm doing.
So take a look. So in this information, what's missing? So in this triangle, what's missing?
Another angle.
Okay, where would that other angle have to be? Based on, look at where they're touching. Yeah. Okay. Right. Exactly. The vertical angle X is there again. Okay.
Angle side.
Okay. You've got two angles. You have a side. Now again, here's the question to see if we've got this. Take a look at where this marking is.
Kind of looks like a triangle.
Okay, but wait. Hold on a second. Which angle is this touching? The first marked angle or the second marked angle? Which one is it touching?
First.
Okay, it's touching the first one. In this triangle, is this one also touching the first one?
Yes.
Yes, it is. So this one is successfully angle, side.
No, that kind of looks like a triangle-shaped football.
There's a reason they don't make those either.
How come?
Granted, footballs fumble around. They're hard to hold enough to hold in the first place, but it's better when they're around. It makes them easier to catch. Less jammed fingers that way. So that's the way those work and stuff like that. So.
Look.
Continuing to be silly there, are you?
But
okay.
It's true.
All right. Okay, but you see now that for between all those different triangles, you see that those are the different things that you're looking for diagram wise, so that you can see exactly what's sort of where the locations of everything has to be to look for. And when you've got triangles that are connected to each other, always make a note to automatically label wherever the triangles are touching each other. If they touch at a single point, you're going to have vertical angles at opposite corners. Mark them off for free. If you've got two triangles that meet at a common line, mark that line off for free.
It's a
whatever the case is.
Pokeball.
Will you stop with that?
But
Okay.
it does look like it.
Stop.
But it does. It does.
Stop. Stop. That's not. No.
But it does.
I'm not going to get her off this mental kick.
But
So
it does.
all right. Okay. So but those are the types of marches. Let me finish my explanation. So those are the types of things that in terms of angles and sides, if they're not already labeled when you have connected triangles, you can mark those off for free. And then from there, compare the locations of the three markings and get them to look like the general versions of these like we saw. If you see exactly those markings in the three required positions, then you've got congruent triangles, and you could say they are congruent by the appropriate rule. If they're not in those correct places in both triangles, then it does not work. You do not have enough information to prove that the triangles are equal. Okay, so that's the story.
Again?
Which one?
diamond poker ball?
No, wait. All this represents is that both triangles.
Like acronym thing.
Well, wait. This alone, you don't have enough information to use any of those rules. You've got to be able to see three markings on both triangles to even attempt to use one of those rules. So with this one alone, that's not enough to prove the triangle's equal. But if you got that, okay, now.
If you see this diamond-shaped Pokeball, that means it's.
Because now here you've got 1, 2, 3 up here. You've got 1, 2, 3 down there. That's enough to potentially qualify it to be a congruent triangle, and that would be angle, side, angle, for instance.
If you see this diamond-shaped Pokeball, you get angle, side, angle. It is a diamond.
I guess we gotta just go with it, folks. I don't know.
Yes.
Sometimes in life you just gotta make up your own rule, as long as it fits the real rule, of course. So keep that in mind. All right. Okay. So Matt, just let me know if that's enough to help guide you through the rest of them. That you've got enough of an idea. If you've got more questions, just let me know. Demore, at the same time as you're looking, please let me know if you've got any further debate on these. So just keep chiming in with more suggestions. And while you're doing, that, okay. Let's see. I'm taking a look at some of Brianna's questions for today. Okay. Well, I'm glad we were able to help you. And hey, stick around and just listen to more of the silliness. Like I said, we can use the company. I said it before on other days. This is good for all of us. On both ends. Okay. So. That's the way that goes. All right, now we did that one. Let me see. Okay, so all right, I'm just taking a look at some of your other information here. Okay, which one do you have next here? Okay, no, I remember those two questions. We did those yesterday. So, okay, here. I see a question here. Let me stay in the geometry a second, Brianna. I want to show you this one, okay? Because this is one that my geometry guys, I didn't really get. I don't have as much of an opportunity to discuss this concept with them, and I want to make sure that they see this because I want to make sure that they see this concept because it is something that, in terms of grand mastery of geometry, it's something that's important to know here. We've been talking about three-sided figures this whole time, Brianna. Okay, let's go into four-sided. Okay, now first, do you know what the general name for any four-sided figure is supposed to be? Now I know in your mind you could think of some four-sided figures. Okay, well here, wait. I'm going to tell you right now. Okay, hold on a second. Okay, so you've got. Wait a second. Hold on.
I don't even know.
Yes.
Spelled it, right?
No, that's exactly how you spell it. Quadrilateral. Yes.
God.
Okay, like I said, any four-sided figure.
Like a B.
Any four-sided figure is called a quadrilateral. Yes, quad is the key word. Quad is the magic word representing four. That's the thing that you want to see there. Now, here's the deal. And a while back, I was even asking my geometry guys in their Alex software or whatever. I'll talk about Alex with some of you general viewers sometime if you've never heard of it. It's actually very useful, and I think more schools should take advantage of it to be able to expand their ability to teach the entire curriculum. But that's another discussion for another time. Anyway, there are some types of quadrilaterals, Brand, that obviously they all have four sides. Okay. And we also talked about it yesterday when we did the sum of angles question. We already said that quadrilateral's got 360 degrees because you can take a quadrilateral, cut it like this, and make two triangles that are each 180. We did that right before we got cut off yesterday. So we know they're 360 degrees, but some quadrilaterals
just doesn't like these types of triangles.
No, it did them.
I'm being silly.
Okay, all right, let's move on.
Maybe they love these so much they had to cut it off. Because they didn't want it to end on anything else.
Shush. Okay.
But maybe.
Here's what. All right. Here's something more specific I want you to see. Okay. Take a look at this figure, as best as I could draw it here. Brianna, take a look.
Okay.
This figure has 4 sides. Okay, but it's got some extra things happening to it. Okay. This is an example. No, wait. Okay, wait. But don't draw the diagonals here. Wait, because that's not the key point of what I want to get to. Okay, I want to deal with these 4 lines themselves. This is an example, to the best that I could draw it, of. Stay with me here. Stay with me here.
YouTube likes these triangles.
Okay, stay with me here. Okay, this is an example of what is called a parallelogram. Now, I know you've seen the word parallel before.
Yeah, it's because it goes like, and it
okay.
won't. I can't do it that straight, but it's because it will go like.
If you were to extend those 2 lines,
they would never touch.
Okay, they would never touch if you extended them. Okay, exactly. Okay, so here's the thing. But what makes a parallelogram, Brad? Wait, follow me.
Kind of looks like a watch.
Shh, hold. What makes a parallelogram is that not only are these 2 sides on the top parallel, and I'm going to use these black arrows to indicate them. Okay, but so are these 2 on these sides. So these are running in the same direction as each other also. When I draw these arrows, they indicate that they're moving in the same direction. Again, the ones with the same number of arrows, the ones that are moving in the same directions.
Yeah.
So that's what you see there. So
you could also do
So that's a parallelogram. Wait! I got 2 more here.
Don't have to draw the arrows. You could go like.
Okay, that's fine. Yeah. Okay. All right. But here, don't take my space because I got 2 other figures I got to draw here.
Looks like a watch.
Don't. Come on. I got things I got to draw in there.
You do?
Yes.
But it looks like a watch, doesn't it?
A mantle clock. Yes. I see
it looks like a watch.
Oh, I see. You with your watch band with the extended things. Okay, I got you.
A watch?
No, I agree with you. But here, yeah. Speaking of a watch, okay, we've got to be a Timex, or YouTube takes a licking, and we've got to keep on ticking. So, all right, let's move on here. Now, let's get even more specific. Let's get even more specific than a parallelogram, because from a parallelogram, there are 2 other figures that we can make here. All right, you know what this one is. You know what that figure is. What's that?
A rectangle.
Okay, here, let's write the name in there. Okay. Losing hold of the rag here. Okay. All right, rectangle. Write it down. Okay. Now here's the thing about a rectangle, Brianna.
Mm-hmm.
Okay, it still has the 2 pairs of parallel sides like the parallelogram does, but it has something extra. Aside from having all the parallel sides, what else does a rectangle have? No. We talked about the parallel. We said that.
No.
Yes.
That's not what I'm talking about.
But don't extend them. That justifies the parallel business. What do you know about this angle right here?
Right.
It's a right. Okay, wait. Here, if you're gonna draw a right angle, you have to draw it like a box. Okay. Are there any other right angles? Are there any other right angles in the rectangle? Anywhere else? Yeah. Yes. Okay. Rectangle. Okay. So here's the idea. The whole idea about a rectangle is that it is a parallelogram with 4 right angles. Okay, that's what that is. But now there's another extension that a parallelogram could have instead. It could be something like this. You know what this one's called? I don't know if you've seen this name before. You might have.
Yeah, rhombus.
Oh, you have seen rhombus. Okay, here's the thing. Okay, wait, here's the thing. Parallel sides here, parallel sides here. Okay, but what's What do you know about a rhombus? What does a rhombus also have to have?
Right.
No. That's what the
A
rectangle has.
parallelogram.
No, wait. It's got the parallel sides like a parallelogram has. It's still a parallelogram, but it has something else. It has 4 of something else.
A acute angle?
No. It's not. No, it actually has nothing to do with the angles. This one has 4 right angles, and
4 even sides.
4 equal sides. 4 equal or congruent sides.
Wait,
Yeah.
Dad, do you know how you said when YouTube takes a looking, we gotta keep on ticking?
I'm just making.
Look, he's cooking the ice cream.
That's not what I meant.
That's the live stream. Tick, tick.
She takes me so literally.
Tick, 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 tick.
I hope you're enjoying it. No, it's.
And then when he finishes the ice cream, that's when the live stream ends.
Let's hope that ice cream cone lasts for a long time. Anyway,
let's hope he really wants to savor that.
Okay, so all right, so here's the story. Here's the story. The rectangle has four right, or we should note, because they're all right angles, they're all congruent. The rectangle is a parallelogram of 4 congruent sides. The rhombus is a parallelogram with 4, this has 4 congruent angles. This has 4 congruent sides. What if it has both? If it has both,
it's a square.
Exactly. Both of these go into the square. This is the perfect version of a quadrilateral because everything about it is completely equal. Everything about it is completely equal.
It was perfect.
Because it has all the equal angles, it has all the equal sides, and by default, the side.
It was perfect.
Don't make it.
Can I draw the other one?
Well, I wouldn't necessarily put the angel wings on it because even though it's the perfect version of a quadrilateral, there is a name that is given to the perfect version of. There's another name that's given to the perfect version of any polygon, which I was starting to say yesterday when we got cut off. Anytime you have a figure like a square where in the polygon all of its sides are the same measurement and all of its angles are the same measurement, there's a name for that. It is referred to as, and this breaks the angelic moniker that you're trying to give it, it's called a regular polygon. That's what the perfect version is supposed to be. Yes. But like I said, it's supposed to be like the exact.
Isn't a square a rectangle?
Look at your question number 8. Which figure is always a rectangle?
Square.
Yes, exactly.
Oh, wow.
You answered the question before I got there. Yeah, because here's the thing.
I used the Expo marker to circle it.
Close enough. You can fix it later. Okay, but that's exactly it, because here's the point I was going to make to you, Brianna, okay? And you guys out there, watch this too, because I've seen this question on a lot of
Dad, look, I fixed it.
Okay,
I just circled the word.
Stop. Okay. Because I've seen this question come up on a lot of test material, not just state test material, but a lot of us teachers like to use this type of question too. When they're trying to identify, like, is a square a rectangle, or is a parallelogram a rhombus, or any other sort of thing like that. Here's the thing: the more details that a figure like these has, you can take a more specific figure and you could call it any of the more generic figures that are named above it. So like you just correctly said, you can call a square a rectangle because a square has 4 right angles like a rectangle does. So a square is also a rectangle. So you can also call square a parallelogram. Yes.
But then where did you put the parallel?
Well, yeah, they would still be here. So yeah, so there's that. But yeah, you can still do that. Sure.
Hurt his feelings by calling him regular.
That's the name for it. I can't help it. I'm sorry if I hurt your feelings. Please do not be sad. Okay, thank you. Okay, so yes, but you can call a square a parallelogram because it does have the two pairs of parallel lines. Okay, but then let me ask you this: can you call a parallelogram a rhombus?
No.
Okay, what's missing from a parallelogram that a rhombus has? What does the parallelogram not have that the rhombus does have?
No. Wait, it is a
Follow the
parallelogram.
definition. Follow the definition. What's missing? What's missing from a parallelogram in order to call it a rhombus? You're missing what? Let's say.
Side.
With the 4 equal sides. Yeah. Well, this does. You could call a rhombus, but here's the thing. A parallelogram you cannot strictly call rhombus because there's no guarantee that a parallelogram on its own has 4 equal sides. So you can't call a parallelogram a rhombus. But the other way around, you can call a rhombus a parallelogram because a rhombus has all the parallel sides like a parallelogram is supposed to have.
YouTube is really enjoying its ice cream cone.
But no, okay, yeah, but do you see the idea of what the problem is? Yeah. You can only call a figure with more details a figure that has less details, but you can't call a lesser one that has more because it doesn't have all the things that the figure with more stuff has. Okay, so that's what I mean when I talk about a generic in this quadrilateral discussion. When I talk about a general versus a specific, a general means it has less details about it between parallelogram, congruence, and stuff like that. It has fewer labeled details. That's what makes it generic. Specific means it has more details labeled on it. So you can call a specific figure a generic one, but you cannot call a generic a specific, not without more details. So a quadrilateral on its own, that's the most generic. A quadrilateral on its own could not be called any of these 4 underneath it. But a square,
because a quadrilateral could be
right, it could go anywhere. But a square, the most specific quadrilateral, can be called anything that is above it because this has all the details that everything above it does.
Oh no.
So that's the way that works. Okay?
Never mind, this is
all right. That makes sense?
Yeah.
Okay. All right. And I hope that makes sense to all of you guys. Please feel free to submit your questions about that if you'd like to see more in that discussion. I might quiz you. Who knows?
Looks like YouTube is really enjoying its ice cream cone. But the ice cream cone is melting.
Well, I hope there. So.
But the ice cream cone is melting. Sad.
Well, I hope not too much.
Yeah, just a little. There's just like a tiny little puddle over there. Just like a tiny.
So who knows there? Okay, let's see. Okay, here.
It's getting dark in here.
No, we're doing fine.
What kind of dark? So
we're hanging in there. Okay. Well, it doesn't. That doesn't do too much, but it doesn't.
Just makes it warmer.
It does enough. Okay. Okay, all right. Explain that to me. I've always wondered for some reason.
It's more of a warm tone than a cool tone.
I guess, but no.
Yellow,
okay, all right. But tell me the truth. Okay. Have your teachers in the past ever done this? And over the years, my kids have always asked me to do this, and I never understand it because honestly, I don't believe that it's true. But no, like when the weather gets hotter. Have any of your teachers had a tendency to turn the lights off in the classroom when the weather gets hotter outside because there's this like mental notion in kids' heads that if it's dark it's cooler. If having the lights on makes it hotter. I get this insistence for years and years and years. Every kid insists upon this, but everything I've ever read said that is not true.
Warmer,
but people still insist on doing it anyway. I don't get it at all.
No, Dad, when I said warmer, I meant it was a warm tone in color.
Well, but yeah, I'm wondering if
No, it's
I'm
'cause
wondering
the
if
light
that's
is yellow.
no, but you know what I'm
not
saying.
white.
But I'm wondering if that's if there's that same subconscious psychological effect, like you're saying, yellow or a white light, like the sun or whatever the case is.
No, since it's yellow, it has a warm tone when it's on, but if it's white, it has like a cooler tone.
Does that make sense to you guys? Because because like I said, I'm still trying to process this logic when anybody ever asks me, no, turn the lights off. No, we want a cooler in here, but that doesn't do anything. Anytime I've ever checked, that doesn't. So
Since
who
we have
knows?
no yellow, it's like a warmer tone than white, because white is cool.
Nah, who
Pretend
knows?
it's like a darker
Anyway.
orange.
All right, find a topic in here. I got another idea on something I want to do, but first, while I'm clearing the board here, you find a topic. Do you see, if you see it, just double check if there's
I
any.
need to see if Ava still needs help.
Yeah, you check that. Okay, I'll tell you what. While you're checking to see if Ava needs any help, and she should be here. Okay.
I don't know if she's just like too shy to actually chat. I don't know.
Okay. Well, here, while you're doing that, here, I'm gonna do one of my discrete topics here for a second. And those of you watching here, okay, follow along with me on this and chime in some answers for me. Help me along with this while Brianne is checking in with her friends. Okay. Because this is something that now my discrete math guys are not doing this right now. They're going to be doing this later on in the year, but I did give them this as an assignment because this is something that you guys out there have seen before, and we do expand upon this when we get into the statistics concept or whatever. So please come join us in junior or senior year, okay? And anybody else out there, just ask me more stuff. Here's what I'm giving them, okay? I'll give you a list of numbers here. Just now, I'm just kind of making these up as we go here. So, okay. I have no idea where I'm going with these numbers right off the top of my head, so we'll find out together. Okay. So, the whole premise here on this question is that okay, we've got some type of experiment or survey or other process that has been done that for each response or attempt that's been made at this stuff, we are collecting a series of numerical data. Okay, and so let's say that for whatever this experiment is, the test has been run, let's see, a total of 9 times here because I've got 9 numbers, and this was the numerical results for that data in all 9 attempts. Now, based on how the data goes, there are several different calculations that I could do with these numbers to try to come up with one single amount that summarizes everything that's going on here. Those calculations, those summary calculations, are what are known as measures. So if I could spell measures of central tendency. Now, there's 2 of them that I'm going to look at right now, both of which have mathematical connotations to them, and you've probably seen both of them before in the past. The first one, which is called the mean. Okay, the mean is just this is probably the one that most people are familiar with. The mean is just a fancy way of talking about the average of a series of numbers, okay? And I'm sure many of you have calculated averages in the past before and stuff like that. All the average means is you just take all the numbers, you add them all up, and then you divide by how many numbers there are, okay? So in this case, we're adding all these numbers, 6, 10, 13, 15, 20, 21, 24, 26, 29. So take a swing at it, grab your calculators, take those 9 numbers, add those all up here. I will do the same thing here just to save myself some time. Ba-doom, ba-doom, ba-doom. Where's my calculator? Okay, let's see. Here, see if you can beat me to it out there. Okay, so we got 6, we got 10, we got 13. We're adding all of these up here. So 15 there, 20 there, we got 21 there, we got 24 there, 26, 29. Okay, so we've got that. Okay, so we add all of those up, and so like I said, yeah, it's so you're taking some of the data and you're dividing it by number of data items that there are. So in this case, I just added up all 9 of these numbers, and I've got a grand total, looks like, of 164. They all come out to when I add those. And as we said, there's a total of 9 numbers here in this set. Okay, so 164 divided by 9. It would have been nice if I had put together a set of numbers that came out to an exact amount. Unfortunately, I did not do that. But hey, when you come up with the numbers totally on the fly, that's what happens. But don't you hate when that happens there, where you're hoping for an exact number and it doesn't come out? You always think, oh, wait, did I do something wrong or whatever? Let me know if you guys get that same feeling sometimes when something doesn't work out to an exact amount. Like in this case, it comes out to 18.2, and the 2 is repeating, meaning, and that's what that bar notation represents, that the 2 just keeps on repeating in the decimal forever and ever and ever. That's the way that works and stuff like that. Okay, so that's the way a mean works. Again, that's probably the most familiar of the central tendency calculations. That's the one people most commonly use. But occasionally, there's another one that people will sometimes use in their work or whatever. This one is called the median. Okay, median. You have to think. Yeah, it sounds kind of like the middle. Okay, and that's essentially what it is. Now, but we have to expand upon the definition just a tiny hair, because it's not, when you read a set of data, it's not always strictly the exact middle number. I say that under 2 pretenses. Okay, it's the middle number in the data when the data is properly arranged from low to high. So you got to make sure that the data is all in numerical order. It can't be all shuffled around. Otherwise, you can't use this rule properly. Now, with the way I wrote this set of numbers, okay, they are already in order from lowest to highest, so we don't have to worry about that part or whatever. Okay. So in this case, because there are 9 numbers in the set of data here, easiest way to do it is if you cross out one number on each extreme of the data, you will eventually work your way in to where the median happens to be. This is the advantage of having double markers here. So, because now we could do that simultaneously. So you ambidextrous people out there get a little extra edge here, because then you can do this simultaneously. I'm not ambidextrous, but I'm coordinated enough that I could do that. I could do that. I could do that, and I could do that. And you can see as a result, I am left with one number there. This number 20 that's here in that set. So that means this 20 would officially be the median of the set of data. And what that represents is that's the number that's at the 50% mark, in a sense, in the data. In that, there is half of the remaining data, it lies below that median value, and half of the remaining data lies above that value. That's the way that goes. Now, when you got an odd set of numbers like this, okay, easy peasy, no problems, no worries. But what if you don't have an odd set of data? What if you have an even set of numbers here? Well, I set up the next problem. If any of you watching know exactly what you have to do when there's an even set of numbers, like the list I'm about to do, tell me what I have to do if you know. Okay, so let's suppose you had this set of data here. Yeah, let's go a little further. Okay, so consider this. All right, what if you had this set of data? All right, so now you only have 8 numbers in this set of data. So if you try to do the same median slash outs like we just did a second ago, if you try to remove one at a time from each side when arranged from lowest to highest, here's what happens. You get rid of those two, you get rid of the 12 and the 28 together, you get rid of the 14 and the 23 together, but here's the problem. If you cross out those two, you don't have any numbers left. So you can't cross out those two. So then where's the middle number? Okay, well, here's what you do. So what happens now is, okay, if you have an even set of data, you have to take the average of the two middle numbers. I should say, or it's going to depend on how many items there are in the set. So you have to just keep making sure to do a high and low from each side and do it as many times as it takes until you have either one number left or two numbers left. Since I've got two numbers left here, that means we're going to add them together. So we add up the 14 and the 22, and we cut the result in half. So we get 14 and 22 is 36, and half of 36 means we have 18 as our median. And once again, notice that 18, again, it lies right smack in the middle. And once again, half of the data is below 18 in value, half of the data is above 18 in value. So once again, this median represents represents the 50%, the 50th percentile. You'll hear that word a lot when you're dealing with a set of data and based on its position in the grand scheme of all numbers. The median would be the 50th percentile mark because again, 50% of the data is below it, 50% of the data is above it. That's the way that works. Okay, so that's how median can play out, whether you have a single number in the middle when there's an odd set of data, or the average of the two in the middle when it's an even set of data. So that's what happens there, and I hope that makes sense to you guys there. So I hope you enjoyed that. And where did I lose Brianna? Brianna disappeared on me. She has so much fun or whatever. Now, see, this is why I've been asking a lot of you guys, please come join us. Keep me company here. You know what I'm saying? Because like I said, I need the social gathering just as much as you guys too. I understand I'm doing it from an educational standpoint, but you've seen the banter and the silliness that we've had here on today's thing or whatever. I've actually enjoyed it. So and I hope you have too. But please come and help join in on the fun. I want to have some social entertainment here just as much as I want to educate. Okay. Hi, Joey. What are you doing?
It says goodbye.
No, let's not say goodbye. It says beauty. What are you looking for?
Oh, this says goodbye.
Okay, well, we're not leaving yet, or at least okay. I hope we're not leaving yet. All right, well, okay, she's back. All right, what's the story, real quick?
So I was able to get a hold of her, but she said like the stream didn't make sense.
Well, wait a second. We're doing stuff that's above her level at the moment and things like that. Remember, I bounce around with any K-12 topics, so throw anything out there you guys want to. All right, but okay, but I'm saying, was there a question about her work that she wanted to know?
Yeah, but she didn't tell me. That's what I'm saying. Submit a question in a live chat. Did you? And got no response.
Who knows there? Well, all right. Well, here then. Before we close up shop, look through your packet here. Is there a question that you want? Okay. let's get a little something of yours in. She's checking her scattered mess of questions here while we...
Wait, I think I know the question she needed help with.
Okay. Because I know from that particular packet you're holding, I know there was a couple of questions yesterday that
It's like
I forget if it was Ava or Gianna or whoever that was asking about this question or that question. Because I know we did a couple of them the other day. I'm sure as you guys are going through your distance learning packets, I'm sure that you guys are bouncing around. You're not necessarily doing the packets in order either, which that's okay. How the heck are we going to police it? All we're worried is that you're getting the work done, and I want to help you. That's why we're here. So
YouTube really likes its ice cream cone.
I'm glad. We'll see how much of this retains when I look at the feed later. But I don't think we've been interrupted. Thank God, or whatever deity you go with. We are not discriminating any religion here whatsoever. Not now, not ever. So
what do you mean?
Don't worry about it. Okay. So anything? Were you trying to call her just now, or?
Yeah.
Okay, she's like, okay, all right, we're here. Real quick. Wait, do you remember vaguely what the question looks like? Which one? Show me. Where'd the packet go?
It wasn't in that one.
Okay, all right. Well, here, wait. If you see it, I'm sure you'll recognize it. No, not that. No, we did that one already.
5 bottles and ounces. It's like 5 gallons and 16 ounces, something like that.
Gallons and ounces. No,
The hunt is on.
No, it's not in this one. Okay.
Oh, what was this?
No, we did that one. We did that one the other day. We did both of those the other day.
Oh.
We did those on Monday, I think.
Forgot the answer.
It's okay. We'll get it back later. We'll check it on yours. No, we did. I thought we did these questions. I recognize these. Yeah, why do you have 2 copies of the same thing? That's strange. Anyway. Excuse us for a minute, folks.
We're just throwing it everywhere. Yeah, draw a little horsey.
Okay, you stop.
Not too good at drawing horses.
1 second. Yeah, no, those are. Yeah, I'm trying to recognize that question too. So, or whatever it is. Okay, wait, hold on. I know there's. Oh wait, here it is. Yeah, here's the question.
Can I see it?
Yeah. Okay. Tom has a water tank that holds 5. That holds 5 gallons of water. No. I just had to find the one that you were talking about here.
Let the horsey live. Let the horsey live.
What's that got to do with this question? Anyway, okay.
Yeah, this was the question. Here, I'm gonna tell her.
Okay, yeah, watch. We're doing it right now. Okay.
Wait. I have to tell her.
Okay, so it says in the question, Tom has a water tank that holds 5 gallons of water. Wait, I'm just writing down the details. You always want to take down your numerical data before you start any situation here. Okay. It says in the question, okay, Tom uses water from a full tank to fill 6 bottles that each hold. Okay. It says it wants to hold six bottles that contain 16 ounces each. Okay, so we got that. 6 bottles contain 16 ounces each. Okay, and there
we hit the finish line.
And there is 1 pitcher. Okay, the pitcher holds half a gallon. So that's okay. Wait, Save me some room.
And look, it's the race to find the question, and we're at the finish line.
Yes, I got it. Yeah, but if you make the finish line too close, I have no room to put the actual map.
Horsey, no!
Oh, calm down. Okay, and the question wants to know how many ounces of water are left in the tank. Okay, so that's the
Still no
So all right,
response.
so all right, well, okay. Well, this is part A of the question because they're doing a couple of different. Okay, well, this is part A of the question because they're doing a couple of different things in these problems or whatever. Okay, so let's see what happens here. Okay, so it says, all right, now, so here's going to be the big thing. All right, the big key here is that to be able to do this question, what you have to know is Brianna, follow me on this. You have to know your units of conversion. Okay, you've got to know the
What's a unit of conversion?
Well, again, remember how we've been doing some questions previously. What was the one we did earlier in the week? Like, no, where we were talking about our different rates and stuff like that. I can't remember the question that we did last week or something like that. But we had to make some measurement. Oh, like when we've done hours to minutes and stuff like that. You know, you have to know what those unit conversion rates are. So here's another one of those questions. The big one that we have to know here is we've got to know how many fluid ounces are there in a gallon. Okay, so here, look it up real fast. Look it up on your phone.
I think it's like.
Check it. Yeah, Google ounces in a gallon. You guys out there do the same thing.
How many ounces are in a gallon?
1 gallon is 128 fluid ounces.
Oh.
Okay. 128 fluid ounces. Okay, so.
Joey, contain yourself.
So, knowing. Okay, go see what they want. Okay. I'll talk to you later. Go help.
Oh, and here's the marker.
Yeah, thank you. Anyway, as I'm losing everything else of mine here. So anyway, here's what it boils down to, folks. Okay, so here's the deal. So knowing that 1 gallon is equal to 128 ounces, so that means then you've got to see, knowing that the tank holds 5 gallons of water, you got to see exactly how many ounces all of that makes up. So let's make it easy. So it means 5 gallons. Okay, just do 5 times 128. So let's see what that is. Okay, 5 times 128. Punch that in. Okay, and it looks like you're going to get about 640 fluid ounces. So that's what you have to start with. That's what you've got to begin with. Now, from there, now we got to get rid of all this. Okay, so it tells us he's going to fill 6 bottles with 16 ounces. Okay, so let's do 16 times 6 here. I'll just acknowledge the 128 times 5 that we did a minute ago, and there's the 640. So you do the 16 times 6 now. Okay, so let me clear the board here. 16 times 6. Okay, so that gives you 96 total ounces. Okay, and then you got a pitcher that holds half a gallon. So you got to know what half of a full gallon is. A half is 128 ounces. So half times 128, there's our fraction times the number that we saw yesterday. Okay, so remember we said divide down. So do 128 divided by 2 and then multiply up to the 1, which multiplying by 1 doesn't do anything. So just do 120. So in this case, just do 128 divided by 2 and you should get 64. Okay, so both of these get poured out of the full tank in the question. So it means if we take these two, if we add those up, okay, 96 plus 6. But I just do it this way. Okay, real quick. 96 plus 64. Go.
Huh?
Now you're back. 96 plus 64. Take down the set.
I was about to fall off the chair.
You set yourself down too hard. Okay, so that means between the 6 bottles of water and the pitcher, 160 gallons.
David, respond yet?
If we take that off of the 640 ounces that the full tank has, how many ounces are left in the tank? How many ounces are left in the tank? Right. 14 minus 6 would give you. Have you got it out there, folks? 400. All right. So that's your answer. 480 ounces of water are still left in the tank after all of this is poured in. Okay. So that's the final answer that you get on that. Okay. Now that was part A of your question, Brianna.
Ava's finished.
Okay. Now let's see. Now let's see what part.
Oh my
Okay.
gosh.
Okay. Chill. Let's get this done because I get a feeling we gotta get out of here pretty fast. Okay.
Why?
Why did you have to go downstairs a minute ago? Okay.
Looks like
now I'm gonna
YouTube is eating his.
Now I'm gonna keep the 1 gallon thing because we're still gonna need that for the other part of the question here. The other question wants to know.
Oh no, Dad! Look, we're running out of time.
Stop. Okay, stop. Come on. Question B now says this. Okay, Tom drinks 4 pints of water a day. How many full tanks of water will he drink in 30 days? Okay, so we know 5 gallons a full tank. Now, they're bringing another measurement here, Brianna. They're bringing pints into the mix. Okay, they're bringing pints in. So here's what we got to see. Okay, ask Siri again. How many ounces in a pint?
Hey Siri. Hey Siri. Hey Siri. How many ounces are in a pint?
1 pint is 16 fluid ounces.
Okay, which is what I thought it was. Okay, so we got that there. All right, so he drinks. Okay, so let's follow this. That's 1 pint. Now, according to the question again, Brianna, it says he drinks how many pints a day?
4.
Okay, so what do we do with the 16?
Divide it by 4.
Says he drinks 4 pints.
Yeah, you divide it by 4.
If 1 pint is 6, Brianna, think about that. 1 pint is 16 ounces. How do you get 4 pints?
You multiply.
Yes, thank you. Okay, 16 times 4, go. 16 times 4, how much are we going to get?
64.
Okay, so that's 64 ounces that he drinks in 1 day. What's the question? How long does the question last for? Okay, so that's 1 day times 30 days. 64 times 30, go. Okay, I know the 0 is there, so just worry about 64 times 3. 4 times 3. Wait, 4 times 3. Okay, there's a carry of 1. 6 times 3 plus a 1. Okay.
How do you find these two?
So that's how much. So okay. So there you go. So that means that's how many total ounces
How do you find these two
that
chairs?
he drinks in 30 days. Okay. So that's how many total ounces he drinks in 30 days. But again, though, the question. Stop. Go back there. So the question then wants to know how many full tanks of water. Okay, guys.
Stop!
You chill too. Come on.
I will.
Don't say anything.
Ouch.
Stop drawing. Here, I need you to cut the drawing for 1 second. We got because we're running out of time. We have to cut this short.
Joey,
Right?
he's taking
We have to
a
stop
marker.
this in it because. Okay, comment, both of you. See, this is what I got to deal with when we're not on broadcast, folks. Anyway,
oh, no,
okay, all right.
running out of ice cream.
Stop.
Okay. Sorry.
Stop.
Sorry.
Because that's when he clowns around.
Oh.
We got to finish this question. Stay with the math here.
Sorry.
Sorry, folks. Anyway,
Sorry.
so we've calculated now how many total fluid ounces he drinks in the 30 days. But the question wants to know how many full tanks of water that is.
Stop it!
Now we did the calculation a minute ago. We said that a gallon is 128 ounces, and a full tank has 5 gallons of water. So we did the multiplication before. We saw that 128 times 5 again. We punched that in. We got 640. So the question is, if a full tank has 640 ounces of water, and in 30 days, he drinks 1,920 ounces. So how do we determine from those two numbers how many full tanks he drinks? This is how much is in one tank. This is how much he drank all together. If I want to know the number of... You divide, okay.
How do you divide that?
Stop it.
Ow!
Stop. I'm not... Guys. Both of you cut it out. Enough. Let's do the division.
I don't know how to do that kind of division.
Well, wait. Here's one thing you can do. They both ends in a 0. We could eliminate those. You could take. Now you can't take all the zeros out strictly. You could take an equal number of zeros out of both of them. So I could take 1 0 off of this and 1 0 off of that. Thankfully, that's all the zeros we got. Now this could definitely be done. Okay. If you're not immediately sure how many 64s there are in 192, make a counting list. So add 64 to that. Add 64 to that.
64 to what?
Add another 64 to 64.
Oh, sorry.
Okay, we need to get to 192. Add another 64. And we got to the 192 exactly that you want. So it takes 3 full tanks. Oh, so he drinks 3 full tanks of water in the 30 days. And there's your answer. Okay, so we got there. By hook or by crook, we got there. So
we needed to erase the horse because we needed more room.
Yeah, apologies for the little bit of chaos that happens there at the end. That happens sometimes when certain people get a little too silly with each other, way too silly.
Yeah, but why didn't we do a video?
I hope you don't mind. I mean, look, we're all human.
Do a video.
Sometime soon, hopefully, maybe. All right. It's not easy. We're all going crazy here, folks. But thankfully,
we needed to erase the horse and stuff because we needed more room.
Well, thankfully they were. Thankfully they were able to see us today. I'm glad the feed it seemed to keep. We'll check after we're done with this and see exactly how much of this held. I hope all of it held, or at least the most significant parts of it, and that it stayed clear on the board or whatever. But we'll find out, won't we? But hopefully tomorrow and the day after, or for however long we do this, hopefully this will maintain and we'll be able to keep on helping you guys. So please, by all means, please come back tomorrow at 2 p.m. and throw us more topics to do. We're ready and able to help you out all times. And if you enjoyed what is that we were doing here today, and that you've enjoyed all of our products here, please hit that thumbs up, hit that subscribe button, and so you can stay so you can stay informed of whenever we do new stuff around here. We really appreciate you joining us, and just like I said, not just for the math lessons, but like I said, for the sometimes over the top silly banter, and just keeping us company in general too. All right, because it's good to have conversations with you guys at the same time while we're doing all this. Okay. See, this is the signal we got to get out of here. So we'll see you guys tomorrow. Take care, guys. All right, and stay safe and healthy and all that stuff.
Bye.